In this first video, we're going to go over the exponential smoothing type of problem. This is the problem 8-6 on your homework. And in this problem, what we want to do is compare the forecasting methods for exponential smoothing using two different alphas, a 0.1 alpha and a 0.7 alpha. And we're going to compare them by their MAD scores. So what we want to do first to get started, because we have to have a forecast number for t plus 1, we use the naive method to get our very first forecast value. So our first forecast value is going to be 430. So we're just going to use previous year's data to forecast our next year's data. And we're going to do that for both numbers, okay? So now we've got all of the variables that we need in order to calculate our first forecasted number. Now, if you want to be able to see a problem worked out, look at your first tab that says level to horizon, and you can see an exponential smoothing problem completely worked out. I've also provided you with a YouTube video here that talks about absolute referencing or mixed referencing, because we're going to be using this type of referencing in this problem in order to be able to copy the cells from, copy the formulas from cell to cell. Okay, so again, the green tabs are the example tabs, and the red tabs are your problem tabs. Okay, so in this first formula spot, we want to put our equal sign in there, and we are just going to be creating this formula right here using cell referencing. So we're going to click on our alpha, do our multiply, click on our A at time t, which is our actual number at time t, which is our first time, which is time 2, plus, we're going to open our parentheses, 1 minus our alpha, close our parentheses, do our multiply, and our forecasted value. And I'm not going to be able to click on it here, so I'm just going to click there and go down. I just moved it down with my arrow, so you can kind of see the marquee going around C5 now. Okay, and that's everything that we needed to put in there. It's the exact replica of this formula, so we can hit enter. And so our first forecasted value is 416. Now, I want to be able to copy this formula down, but if I try to do that, let me show you what happens. Go back to my sheet here. If I copy that formula down, then you can see that it's going to move off of the alpha value. So this is fine, it moves down here fine, and it moves here fine. But it's moving off of the alpha value, which I don't want it to do. I want it to stay stationary on that value. In order to make it stay on this value, I have to use what is called absolute referencing in my original formula. So I'm going to come back up to my 416 here. And in my formula bar, wherever I have C3, I'm going to put my insertion point in the middle of C3. And hit my F4 key. I'll do that on both spots here. And once I get that in there, I'm going to hit my check mark, lock in that formula. And now when I copy the formula down, and I double click here, now we see that that formula is correct. And that is the power of absolute referencing. Okay, and I'm ready to do that exact same process over here. I'm going to put in my equal sign, click on my alpha, my new alpha of 0.7, times my actual amount, which was the 289, and add that to, open parentheses, 1 minus the alpha, close the parentheses, times the forecasted number, which again I'm going to have to kind of move to it, and you should get 331. Again, I'm going to come up to my formula bar, put my insertion point in the middle of my E3, and hit my F4 key. Both spots there. Click on my check mark, and then I can get on my fill handle and drag down. Okay, now that I have my values in there, I can figure out my error. Alright. Now that we have our formulas in there, we can now calculate our error. Our error is the difference between the sales that we forecasted and the sales that we actually made. So what we want to do is we want to do a subtraction here. But in order to calculate our MAD score, we need to know the absolute value. So we don't want to have any negative values. We want to know the absolute value of that difference. So we're going to do a function here. And in order to find the correct function, we can use our insert function button. And if you type in absolute right here, make sure you have all chosen right here and click OK. It should come up with the absolute function argument here. And we only have one blank that we need to fill in, and we're going to put our formula right inside this text box. So we're going to do our 289 minus our 430. Make sure that you just click on the cells, that you don't type in the numbers. I'm going to click OK. Once we've got that in there, we can copy that all the way down. We're going to do the same thing over here. We're going to do an equals absolute our 289 minus our 430, close our parentheses, and we're going to copy that all the way down. Then we want to add up the total of all of our absolute values. So we're going to sum that up. Same thing here, sum that up. Then we want to divide by the number of weeks that we forecasted. So we didn't forecast a total of 6 weeks, we only forecasted a total of 5 weeks. So we need to do 6 minus 1 here. So we're going to do equals, click on our sum, divided by our 6 minus 1, because we did not forecast in week 1. Okay, same thing here. Do our equals, click on our sum, divided by our week 6 minus 1. And what we want to do to determine which is better is find the one with the least MAD score. The higher the MAD score, the larger your error was. So we want the one with the least average error. So the MAD score on our 0.1 was lower. So therefore our forecasting was better on our 0.1 alpha than it was on our 0.7 alpha.